Section 6.4, transformations of exponential and logarithmic functions. These rules for transformations, regardless of the function, whether it's exponential, logarithmic, polynomial, quadratic, cubic, linear, absolute value, the rules for transformations are exactly the same no matter what type of function you are using. Okay, so what I've got here, I've got a chart. You can see how it kind of looks. Three main transformations. We got translations, reflections, and then stretches or shrinks, and then we split them into horizontal and vertical. Translations, reflections, and stretches or shrinks. Okay? So, just as a reminder, for horizontal translations, that is when we add or subtract from x. Okay? So if we wanted, it could be something like this. We could say g of x is equal to 4 to the x plus 2 power. Okay, see how it's directly from x. If we wanted something, that would actually be an example of a translation 2 units to the left, okay, of the original function 4 to the x power. Or if we wanted something with logarithmic, we could say h of x is equal to the log of x minus 1. Okay, notice that x minus 1 is in parentheses. That's the minus 1 is being taken directly from x. If we didn't have the parentheses, if we had the log of x minus 1, that implies that the minus 1 is from the end of the function, which then is no longer a horizontal translation. Okay, so let me get rid of the blue one here. Okay, so there's a couple of examples of horizontal translations. We add and subtract directly from x. For a vertical translation, like I said just a minute ago, we add or subtract still, but it is from the entire function. Okay, so an example of an exponential, we could have g of x is equal to 4 to the x and then plus 7 on the end. There's a huge difference between if it's plus 2 or plus 2 or 7 or whatever number, if it's with the exponent directly from x or if it's on the end. This one on the end means it's vertical. This one with the exponent is horizontal. And again, with logarithmic functions, works the same way. H of x is equal to, we could say the log of x, and then let me erase that. We could have minus 6. Okay, so this one would be an example of sliding up. This one's just sliding down, right, and left. Okay, so there's translations in a nutshell. For reflections, for a horizontal reflection, so that would be going from, like if we thought this was the xy plane, a horizontal reflection would be this way, from quadrant 1 over to quadrant 4. So that would be over the y-axis. Okay, and a reflection over the y-axis means we multiply x by negative 1. Okay, we multiply x, and just x, by negative 1. So an example could be something like g of x is equal to 2 to the negative x power. We're multiplying x, directly x, by negative 1. Same thing with a logarithmic function. H of x is equal to the log of negative x. Okay, that would be an example of a reflection over the y-axis of a logarithmic function. Okay, with vertical reflections, that would be going from something like quadrant 1 up here down to quadrant 4 down here. Okay, that is when we multiply the entire function. Multiply entire function. And again, we're multiplying it by negative 1. Multiply the entire function by negative 1. So an example of a exponential function could be something like g of x is equal to negative 5 to the x power. Notice the negative sign is now out front. And for logarithmic, h of x is equal to negative log of x. Okay, that would be an example of a reflection over the x-axis, going from quadrant 1 up here down to quadrant 4, or you could say quadrant 2 to quadrant 3, or vice versa, 3 to 2 or 4 to 1. Okay. For stretches and shrinks, very similar to reflections, but it's not going to be the number we're going to multiply x or the entire function by is not going to be negative 1. We're looking more at the absolute value of that number. Okay, so for stretch or shrink, remember it's not multiply x by the reciprocal of your factor. Okay, multiply x by the reciprocal of your factor. If we're talking a vertical stretch or shrink, then we multiply the entire function. Multiply the entire function by your factor. Whatever number you want to stretch or shrink it by, that's what you multiply by for the vertical stretch or shrink. Let me extend this table just a little bit. Let me give you an example. So for a horizontal shrink, we could say something like g of x is equal to 2 to the 2x. Okay, that's this 2 right here, this one, that's the reciprocal of the factor. So the reciprocal of 2 would be a half, which makes the stretch or shrink, it's actually going to be a horizontal shrink because our number, the actual factor, is between 0 and 1. It's a small number. Okay, for a logarithmic function, we can have something like h of x is equal to the log of, we could say 1/3 x. Okay, this would be a horizontal stretch because this number right here is a 3. Let me erase that. Let's try that again. 1/3. Not much better, but it's a 3. Okay, remember that's the reciprocal of the factor. The reciprocal of 1/3 is 3. And if that number is bigger than, if the factor is bigger than 1, then it's a stretch. Okay, so the red one that you see there is a horizontal shrink. The green one would be a horizontal stretch. For the vertical side, we could have something like this. G of x is equal to 4 times 2 to the x power. That would be an example of a stretch because what we're multiplying by right here, this 4, that is a number bigger than 1, so it's a stretch. And then give me a logarithmic one, h of x is equal to 1/4 log of x. That would be an example of a shrink because this number that we're multiplying by is the factor and it's between 0 and 1. It's a small number, makes it a shrink. Okay, so there's kind of the overview of the transformations. We got translations, reflections, stretches, and shrinks. The rules that we learned back in Chapter 1 and Chapter 2 don't change. The rules still apply for all 3 types of transformations: translations, reflections, stretches, and shrinks. We're just now applying it to a different type of function. Okay, so now we're working with exponentials and logarithmic functions. Okay, so let's do a couple of examples here. Describe the transformation from f of x to g of x and then graph each function. So, number 1 here, f of x is equal to 1/3 to the x power, and then g of x is equal to 1/3 to the x power minus 5. Okay, the minus 5 is not part of the exponent. So the first part, this stuff that I've got under, whoops, that's supposed to be yellow. Let's try that again. Yellow. Let's do this first. Describe the transformation from f of x to g of x. Well, if I look at f of x here, this one, and then I compare it to g of x, the only thing that changes is this minus 5. And it's on the end of the function and we're subtracting. Anytime we're adding or subtracting, that's a translation. Whoops, whoa, holy smokes, let's try that again. Translation, hit the wrong button there. Translation 5 units. And remember, with vertical translations, since it's on the end of the function, it's a normal direction. So anytime we see minus, that means down. 5 units down. Alright, so the second part, graph the function. I'm just going to do some sketches. You can feel free to do some sketches as well. I know that 1/3 to the x power is going to look something like this. Okay, it's an exponential decay function. It has that general shape. Anytime we're going to go 5 units down, that means we just take each point. Let's say I hit a point here, I got this point here, this point here. All I'm going to do is shift them 5 units down. Okay, so now my new picture would look something like that. So the red one would be f of x, the yellow one would be g of x. And all of these points from here to here are all 5 units apart. Okay, it's just 5 units down. Okay, so there's example number 1. Number 2, f of x is equal to e to the x power. G of x is equal to e to the x plus 3 power, and then plus 2 on the end. Okay, so we got a couple changes here, going from f of x here, this one, down to g of x. The two changes, the plus 3 up top, the plus 2 on the bottom, or on the end of the function. Anytime you're adding and subtracting, it's a translation. If it's directly to x, it's left and right. If it's on the end of the function, it's up and down. We've actually got both. Okay, so this is a translation. We're going to go 3 units and 2 units. The plus 2 on the end, that's the vertical side of it, so that would be up. The 3, this one right here, remember with horizontal translations it's always backwards. Normally we think plus 3 would be 3 units to the right on the number line, but with translations it's backwards. That's actually going to be 3 units to the left. So there's our transformation. It's just a translation, 3 units left and 2 units up. So if I was going to graph this, I know e to the x looks something like this, has that general shape. This is e to the x, or I guess I'll just rewrite that as f of x. Okay, then for the transformation, we just need to follow these steps here in yellow. 3 units up, so if I had this point here, I go 3 units up, 1, 2, 3, 2 units over, 1, 2, now that point is there. Okay, the graph is going to look very similar. It's just going to look something probably like this. And it will flatten out over there. And that would be g of x here in yellow. Okay, so that's an example of another translation with another exponential function. Let's try a couple, and I'll erase this here. Let's try a couple with logarithmic functions. Number 3, we got f of x is equal to the log of x. Okay, and then g of x is equal to the log of negative 1/2 x. Okay, so we've got a couple of different things happening here. We got the 1/2, and we've also got the negative. Okay, the 1/2, actually let's start with the negative. We'll start with the green one. The negative, it's inside the parentheses, it's directly to x, so that means it is a reflection. Anytime you have a negative and you're multiplying, it's a reflection. And the question becomes, is it in the x-axis, meaning vertically over the x-axis, or horizontally over the y-axis? If it's directly to x, it's always going to be horizontal. So it's a reflection in the y-axis. That's what the green one says. The green negative, or the green underlined negative sign, since it's directly to x, inside the parentheses, it's a reflection in the y-axis. Now, the multiplying by 1/2, again, it's directly to x, so it's a horizontal change. Horizontal. Now we need to figure out if it's a stretch or a shrink. Let's figure out the factor first. So it's a horizontal something by a factor of, well, this 1/2 is the reciprocal of the factor. The reciprocal of the factor, the reciprocal of 1/2 then would be 2. Okay, so if the factor is bigger than 1, that means it is a stretch. Horizontal stretch by a factor of 2. Those are the two changes from f of x to g of x. Okay, so when we go to graph, and again, I'm just sketching here, log of x looks something like this. This is f of x here. Now I'll do graph g of x in red. So I need to do a reflection in the in the y-axis. So I'm going to go from this side over to here. So my general shape is going to look something like that. And then I need to horizontally stretch it out by a factor of 2. So it's going to get a little wider as well. So it's going to look something kind of like that. It's a little wider, a little flatter, and it's obviously reflected over the y-axis. This would be g of x there. Okay, hopefully those make sense. There's another couple of examples in the textbook. Feel free to look in those. Also, there'll be some in your assignment like this, where you have to kind of sketch the graph and describe the transformations. Okay, last little piece in this section. Directions say write a rule for g. So with this program that I'm using, I can't really type any equations. So I got to write the equation here for f of x. So f of x is equal to 2 to the x. And to get to g of x, we need to follow these steps. A reflection in the x-axis, followed by a translation 4 units right. Okay, so we're going to start with f of x equals 2x. Let's do the reflection part, the first part, in red. If we're going to reflect something in the x-axis, that means we need to multiply the entire function by -1. Because remember, the x-axis would be from like quadrant 1 up here down to quadrant 4. So that would be a vertical reflection. And if it's vertical, it's always to the entire function. Okay, so if we're going to multiply it by -1, we're going to have just -1, or just -2 to the x. Pretty straightforward. Okay, now we need to go ahead and do the translation 4 units right. Okay, anytime we're going 4 units right, horizontally, anytime it's horizontal, we're going to be going directly to x. Okay, so it's going to be right to there. And since it's a translation, we're going to be adding or subtracting. Okay, so we'll have -2. Now, 4 units to the right, normally 4 units that way, we'd think plus. But remember, with transformation or translations, it's going to be backwards. We're actually going to use a minus sign. Okay, so we'll have x minus 4 up in the exponent. And this right here is your final answer. G of x is equal to -2 to the x minus 4 power. Okay, really just as simple as that. The red one takes care of the reflection, the green one takes care of the translation, and then you're at your final destination. G of x is equal to -2 to the x minus 4 power. Alright, let's try another one here. Number 2. I don't know if I'm going to have enough space for this one, so we're just going to write it down below. F of x is equal to 1/3 to the x power. Okay, we have 3 different transformations here. We got a reflection in the y-axis, then we have a translation 3 left, and 2 down. Okay, so let's start with the one that's listed first, the reflection in the y-axis. A reflection in the y-axis, that one goes from like quadrant 2 over to quadrant 1, or quadrant 4 over to quadrant 3. Okay, it's a horizontal reflection, and anytime it's horizontal, it's got to be directly to x. Okay, so we're going to have 1/3, and if it's a reflection, that means we multiply by -1, so -x there. Okay, so there's the reflection in the y-axis. Now let's take care of the 3 left and 2 down. Let's start with 3 left. So we got 1/3 to the negative. Now there's x. Anytime it's left, it's directly to x, not -x. So make sure you use parentheses here, because you will get the problem wrong if you don't put parentheses, because it won't be technically correct. You'll be subtracting or adding directly from -x, but that's not the right method. You need to add or subtract directly from x, and only x. So a translation 3 units left, normally that's this direction. Normally we think that's subtract, where we take away on the number line, but that with translations, horizontal translations, it's always backwards. So this is going to be x plus 3, and then for 2 down here in green, it's vertical, so it's going to be normal, and since it's down vertical, we just put it on the end, and it'll be -2. Now, if you left it just like this, that would be perfectly fine. If you want to simplify it a little more, you certainly can. We'll do it here in yellow. We can, this will be g of x, we can clean this up just a little bit. We can distribute a -1 to the x and the 3, so we could have 1/3 to the -x plus 3 power -2. Either one of these two, either that one or that one, would get you full credit on a quiz or test. Alright, let's try one more here. Number 3. Your original function, f of x, is equal to the log base 1/3 of x. We're going to be doing a translation 2 units up, then a vertical stretch by a factor of 2. Now, it's important that we keep this order of transformations. 2 units up, then a vertical stretch by a factor of 2, because that definitely changes your answer if you switch the order. Okay, so let's start with the translation 2 units up. Again, it's translation, so it's adding and subtracting. Up is obviously vertical, so we're going to just add 2 to the end of the function. Okay, so we'll have the log base 1/3 of x, and then plus 2, not in parentheses. If we wanted it in parentheses, or if we wanted a horizontal translation, we would put parentheses. But we don't want that, so we're not going to put parentheses. That takes care of the translation 2 units up. Now we got to talk about the vertical stretch by a factor of 2. If it's vertical and a stretch, we're going to multiply the entire function by our factor. In this case, it's 2. Okay, so we'll have 2 times the whole function, not just the log, the entire function. Log base 1/3 of x plus 2. This is going to be distributive property. We can take 2 times the log base 1/3 of x, and we can take 2 times 2. Okay, so what this is going to look like is 2 log base 1/3 of x plus 4. Okay? Thinking back to the Chapter 5 quiz, or excuse me, the Chapter 5 test, the square root part where we transform the square root functions, definitely a lot of people got that wrong because they didn't multiply the entire function. They would do the first part with the square root, or in this case a logarithm, but they wouldn't do the second part. You need to multiply the whole thing if it's a vertical stretch or shrink. Now, if you left it as this on a test, that is perfectly fine. Okay, you're just showing that you know the order in which things happen. You just didn't clean it up enough. This would be better, but either one of those two lines in blue would get you full credit.